Hi everyone, this is Aaron. This is video 6 of the tutorial, and it's also going to be the last video in this playlist. But don't worry, the tutorial will continue in a new playlist called Programming with TI. Spoiler alert, it's gonna be super cool. But before that, I'll wrap things up in this video and talk about calculus, distributions, and vectors. Let's get started. Okay, so first I'll talk about calculus. In calculus, there are two fundamental operations, differentiation and anti-differentiation, and there are shortcuts on the calculator for them. To use differentiation, you can do shift minus, then you would specify the variable and type in the expression to get the derivative. And to anti-differentiate, you can do shift plus. Then you can use the terminals to calculate the definite integral, or you can leave them blank to calculate the indefinite integral. Now note that the constant plus c is not included here, so you'd have to remember that yourself in a test setting. Okay, so next let's go to the actual calculus module. And I'm sure you know most of these comments, so I'll just go through the more complicated ones. Okay, first one is arc length. Now the arc length just calculates the arc length of a function between x equals a and x equals b. And to use it, you will simply type in the expression for the function, specify the variable, and type in the two terminals, like this. Yep. And we've got the arc length. Nice number. Right, okay. Let's move on to the next one. So, okay. Next one is differential equation solver. Now you can either use the window here, or you might just type in the command, which is dsolve. And then to use it, you will need to specify the derivative by doing y prime equals the derivative and specify the two variables. Yep, and now you would get the indefinite integral satisfying the differential equation. And if you want to solve when the initial condition is known, you can specify the initial condition using the AND operator like this, and then you would actually got the unique solution. Okay, so next let's talk about implicit differentiation. So here you would basically what this does is it calculates the gradient function of a relation, and so to use it you will need to specify the relation and then specify the two variables. Now note that the order does matter, and you must write the independent variable before the dependent variable, otherwise the thing would be messed up. Yeah, and that's it for the first section. Right, so next let's talk about distributions, in particular the normal distribution and the binomial distribution. So a normal distribution is just a bell curve, and most of the times we're interested in finding the area under the curve. And you can do that by doing menu 552. So for example, maybe let the lower bound be 40, the upper bound be infinity, the mean be 30, and the standard deviation be 7. And here we've got this number. Now you might notice that the numbers I entered isn't really random, and you're right. In fact, this models how the study score is calculated, because the mean of the study score is 30, the standard deviation is 7, and so what this means is that if you want to get a study score of 40 or above, you need to be in the top 7.66% of all the students in Victoria. Right, and of course this thing has an inverse, and which is menu 553. And here you can enter the area. I won't change the mean and the standard deviation here. So basically what this means is that if you integrate the bell curve from negative infinity to 0.84. The area under the curve would be 0.8. Right. Okay. So next, let's move on to binomial distribution. And a good analogy would be flipping coins, because the likelihood of success in each trial is the same. And sometimes you may be wondering, what is the likelihood of getting, say, 7 heads when flipping the coin 10 times? And you can do this. Turns out the probability is 0.117. And if you want to find out what is the probability that the number of heads is between A and B, you can do binomial CDF, which is cumulative. For example, maybe you're interested in getting between 3 and 5 heads, then you do this, and the probability is significantly higher. Yep, and that's it for distributions. Okay, so last but not least, let's talk about vectors. Just a quick reminder, the easiest way to represent vectors in TI would be to use a row matrix, such as this. And then this will be your I component, J component, and K component. However, in terms of high school vector, TI doesn't really have much useful commands. And in my opinion, there are only 3 really useful commands. The first one is norm, which gives you the magnitude of a vector, and you can verify that yourself. The second one is unit v, which stands for unit vector, and it will return the unit vector given a vector. And the last one is .p, standing for dot product, and it gives you the dot product of 2 given vectors. Right. So even though these 3 commands are very elementary, you can still do interesting things by playing with them. For example, you can define your own function to find the vector resolute between 2 functions. And you would basically just type in the formula for Dr. Resolute and save it as a function. And then it's done. So then if you want to find the vector resolute between 2 vectors, it would be extremely easy. Here it is. It's pretty cool, isn't it? And in my next playlist, I'm going to delve even deeper into this and talk specifically about how to define your own functions and programs in the TI-Nspire calculator. So if you're interested, please subscribe, and I'll see you in future videos. Yep, and that's it for today. So thanks for watching, and I'll see you next time.